Hi guys, in this lecture video I wanted to just quickly talk about pointers. I'm not going to go into it in too much detail because we're not doing a lot with pointers in this class, but I wanted to at least introduce it. So I'm going to skip a couple of slides here and then just get to the slides that I want. So what is a pointer? A pointer variable is a variable that basically holds a memory address location. Okay, there is no name associated with a pointer data type, and therefore when we declare our pointers, we declare them with the data type of the memory address that the pointer will point to. So for instance, if identifier points to a memory address that can hold integers, then that's the data type we will use for our pointer. So the syntax for creating a pointer variable is the data type of the memory location that it's going to point to, the asterisk symbol, and then a name that you give your pointer variable. Now, the name you give to your pointer variable is the same as any kind of variable naming scheme. Again, you cannot start with a number, you can't have special characters. You'll find that when it comes to pointers, if you're looking at others' code, tend to use single letters for pointer variable names. So here are some examples. This is a pointer P that will hold the memory address of a location that holds integers. Here is a pointer CH that will hold the memory address of the location where you will hold chars. In fact, all three of these statements are appropriate. So you can have the asterisk next to the P, you can have the asterisk next to the int, or you can have the asterisk in between the two if you were declaring a variable called P, for instance. That's a pointer variable that holds an int memory location. All three are equivalent. However, this one is the one that's used more often, is when you want to keep the asterisk next to the variable as opposed to keeping it next to the data type or with a large space in between the two. However, that doesn't mean you're incorrect if you use any of these other two, because as you've noticed, they're all equivalent. It's just this is the kind of the recommended version to use. So if we were to keep our asterisk next to the data type, it will cause a confusion, because if you look at this statement, the P is the pointer here, and the Q is just an integer variable. Okay, now by putting the asterisk next to the data type, it will cause someone who's reading your code confusion. They might think that both of these are pointers, whereas only one is. Okay, that's why, to avoid confusion, we attach the asterisk character to the variable name. That way it's easier to tell. So if you look at this statement right here is the equivalent to this statement. They're both the same, except of course the bottom one is a little bit easier to read, because basically we're saying P is a pointer that points to a data location that holds integers. Q is just an integer variable. Okay, now if we wanted both of those to be pointers, we would need an asterisk both times, and you'll notice in this case both P and Q are pointers that points to memory addresses that holds integers. Okay. The ampersand is the operand used for the address of a memory location. So when you want to actually set a pointer to a memory location of a variable, you would use the ampersand. So for example, here we have a regular integer variable x, which has the number 25 inside. Here we have a pointer P, so the pointer contains the memory address of the location that can hold integers. So by stating this last statement here, we're basically saying that pointer P now points to the address of variable x. Okay, so if we actually do this in our code where we see out asterisk P, what will actually show on the screen is the number 25. Okay, now if we actually use asterisk P and then we set it to 55, and then later we go ahead and do a cout statement of x, the number 55 will actually display. Even though we've changed P to 55, it's the x that will change to 55. So graphically speaking, we basically have a variable location called x that has a 25 in it based on this line of code. In the next line, we have basically a variable called p that only holds memory locations. And then in the next step, the third, we have p pointing to the address location of x. So it's p is actually looking at, so let's say address location of x is 1001, and this means the same thing. Then p is now 1001, so it contains the address location of x. Okay, so when we do cout p, what we're doing is, okay, go to p holds the address location 1001. Let's go to that address location 1001 and then display what's inside. So the number 25 will display to the screen. And then here, when we say p asterisk p set to 55, that's exactly what's happening. We're going to, okay, p holds the address location 1001. We go to that address location 1001, which is x, and then we're changing it to 55. So what happens is this 25 gets overwritten by the 55. So now if I do cout x and the cout asterisk p, both should print out 55 after the change. Okay, so that's what a pointer is. Okay, in fact, this is a graphical representation right here. So here I have a num variable that holds or stores the number 78. Then we have a pointer variable being set to the address of that variable. And then now we're putting that pointer data to 24. So let's see what's happening. So when we first create a pointer variable p, so pointer variable p is at address location 1200. The regular variable num, which is an int variable, is at address 1800, excuse me. Now, as soon as p is set to the address location of num, look what's happening. P has 1800 as its data, which is where num is, okay? And then as soon as we say, okay, take what's in p and set it to 24, notice what's happening. Well, what's in p is memory address location num, and then it's in this address location num that we set the 24. Okay, so that's basically what a pointer is. A pointer is a variable that holds as its data a address location. Address location. Okay. So you can declare pointers to other data. For instance, well, obviously we're not dealing with structs. You probably don't even know what structs are. Maybe you do. But it's come to something similar to a class, as you can see. You can create a struct object using a pointer. So you can create a pointer struct object. So I'm going to skip over that a little bit. So why do we use pointers? Pointers are used for dynamic variables. Everything we've been doing up until now, we've not been using pointers, so all of our variables have been static variables. What that means is that that memory address is set aside prior to our program compiling. So with static variables, which is what we've been doing since week 1, all of the memory address is set aside by the computer prior to your program actually compiles. The difference between that and dynamic? Well, with dynamic variables, the memory address locations are created during execution. So that means you've already hit compile on the Visual Studio and you have that black console window open and your program is running. That's when the variable locations are set aside, is during execution. Okay, so pointers are the only way in C++ to create dynamic variables, variables that are created during execution as opposed to before compile time. Okay, so in order to create these dynamic variables, we use these keywords new. Now, anytime you dynamically create a variable, meaning create it during execution, when your black console window closes, you have to also release these memory locations so that the memory locations can be used in other programs afterwards. So not only do you use new to dynamically create variables in C++, you also need delete to release the memory, because remember, we're dealing with temp memory this entire time. So we need to release that memory before your program closes. Okay, if you don't, or if you forget to release, what happens is now you have temporary memory being set aside for something that you're no longer using. And so that memory is going to be permanently set aside as being used, whereas it actually isn't, and therefore you have not released it. So that memory location would be set aside forever. Well, until at least you turn off your computer, turn it back again. But there can be future horrible things can happen with dangling pointers, which we're not going to cover. But so just remember that delete is very important when it comes to dealing with dynamic allocation of memory. So how do you use new? You can use new in two different ways. You can use new to allocate one variable. You can use new to allocate a series of data in arrays. Okay. So for example, here I have a pointer called name that can hold chars. Well, a pointer called name that will point to a memory location that can hold chars. And then as you can see, I can use new, the keyword new, to allocate either a single variable or an array. And as you can see, in this case, we're dealing with an array. So all I do is point or put that pointer, set it equal to, using our keyword new, the data type, and then the array symbol, right, the square brackets, and then the number. So all we've done here is we've dynamically allocated an array that can hold 5 chars. Here we have a pointer p, and in this case we just set it to 28. So we've just allocated, well, first we've allocated just the one integer location, new integer location dynamically. Then we've set 28 in that location. Okay. And then finally with the string pointer, string or str, well, we use the new keyword to just create one memory location that can hold a string, and then dynamically. And then we're also storing in that location the words sunny day. So new allocates location, and then delete is used in these two ways to delete that location once your program closes. So you will either delete the pointer variable if you've allocated just a single dynamic variable, or you will say delete and then the array brackets and then the pointer variable if you allocated dynamically an array. So it really depends on which you did through during your program. All right. I don't think I want to get into anything more than that, so let me go ahead and get out of this PowerPoint. The next thing I want to talk about is what you're doing for this lab. So in this lab, what you're doing is you're actually creating dynamically objects of the employee class. So instead of doing what you've been doing in the previous weeks, where you create static objects, you're actually creating dynamic objects. So the difference is right here. So I'm trying to get this to be a little bit larger text, excuse me. This would be the old version. So here you're creating an employee1 object of the salaried class while passing in some parameterized information to the object. Here you're creating an hourly object called employee2, again passing in some parameterized information as you're creating it. So this was the old way. This is how we've been doing it in the weeks 1 through 5. And then if you wanted to create an employee object, so here's employee3 object, that's from the employee class. However, if I wanted to use the employee class as my type, but I wanted my object to be a salaried object, you can't do that. So can't make employee3 a hourly object or a salaried object. Why? Because right here we put the class name right in front of the object, and therefore with static memory location, the computer has already bounded or binded this object to the employee class. So you can't make it an hourly or a salaried object at all. Employee3 is an employee object. However, with dynamic binding, dynamic allocation, you can do that. So let's take a look at these two lines of code here. Here I'm creating a pointer object called employee list1, and notice the type, it's employee class. However, on the right-hand side, I'm creating a new, remember we talked about new being the keyword used to dynamically allocate memory. So we call new, and notice which classes constructor we're invoking. We're invoking the salaried classes constructor. And because things are dynamically allocated when you're using pointers, meaning this is created or this line of code is actually executed during runtime when your program has already compiled, the computer is able to understand this and actually make employee list 1 a salaried object with 10,000 as a salary, 3 as the management level, even though over here we said that this was a pointer employee object. Okay, we're actually able to bind an employee object to be a salaried object using dynamic allocation. Whereas in the old way, the salaried, I'm sorry, in the static allocation, we cannot do that. So if you wanted employee 1 to be a salaried object, we have to declare it as a salaried object. If we wanted employee 2 to be an hourly object, we'd have to declare it as an hourly object. We cannot declare it as an employee object and then later on say, oh, actually, this is going to be an hourly or a salaried object. Cannot do that. But with dynamic allocation, you can. So here we have an employee list 2 pointer of the employee class, but we're creating new hourly, and we're calling the constructor here. And by doing that, right away, employee list 2 is now considered by the computer as an hourly object. Okay, so what else is going to be new now for the week 6 lab because we're declaring our objects this way as opposed to this way? Well, big difference is in the old ways, we have an employee 1 object, an employee 2 object, correct? So if I wanted to call the display employee function using the employee 1 object of the salaried class, I would have to do this, employee 1, and then use the dot operator and call display employee. Right? So this would call the display employee function in the salaried class using my employee 1 object. And then same for employee 2, I would have to do this. This will call display employee function in the hourly class using my employee 2 object. So notice we use the dot operator for both. But when it comes to dynamic allocation, what you actually now have to use is the pointer operator, which looks like this, which is a dash and then the greater than symbol. So if I wanted to call the display employee function of the salaried class here, I would have to actually do this. And if I wanted to call display employee from the hourly class, okay, so notice the difference is that in the old way we use the dot operator. In the new way we need to use the pointer operator. So we use employee list 1, which is a pointer object of the employee class. However, it's been bounded or binded to a salaried object. So employee list 1, you could actually just use it as if it is a salaried object from the salaried class. So when I do this, I'm actually calling the display employee function in the salaried class. With employee list 2, it's been bounded to an hourly constructor using new, and therefore employee list 2 is now considered an hourly object. And therefore, when I call display employee using employee list 2, I'm actually calling display employee from the hourly class. The only other thing difference, of course, between the old way and then the new way is in the old way, I don't have to delete my objects when I'm done. I'm just done. In the new way, because these are dynamically allocated pointer objects, remember using my keyword new, and from the lecture slides, you saw that anytime you use new, you have to use the keyword delete. So at the end of your program in int main for the week 6 lab, you would need to, and because these are not arrays, we don't have to use the syntax for deleting array pointers. We're actually just one array object each. So we just do a delete employee list 1, and then we're going to need to do a delete employee list 2. So we have to release the memory that we're actually setting dynamically during runtime. All right, so we use new to create, and we use delete to release dynamic variables. So just remember these syntax, and you should be fine with the week 6 lab. Again, you're dynamically allocating objects and dynamically binding them to the right class using new. And then you're using the pointer operator to call your functions now, as opposed to the dot operator, which you've been doing before. And then at the end of your program, you do need to delete your dynamically created objects. In my case, it's employee list 1, employee list 2, and notice I just go ahead and delete them like that using the keyword delete. All right, that is kind of my lecture for this week regarding pointers. Again, pointers are basically another variable, but the variable actually holds a memory location. Okay, so that's kind of probably the most confusing part regarding pointers. But pointers are necessary if we want to dynamically allocate as opposed to statically allocate. That's kind of the only reason why we use pointers. All right, thank you very much, and I will do another lecture for next week. Thank you. Bye-bye.